Hi everyone, today's video is a continuation of our previous two videos wherein we studied the IoT functional blocks and IoT communication models within the logical design of the Internet of Things, that is IoT. So, today we are going to study the third functional element, that is the IoT communication APIs of the logical design of Internet of Things. So, let us see what IoT communication APIs are. When I say IoT communication APIs, so for that I need to know first of all what APIs are. API basically stands for Application Programming Interface. I am sure many of you must have heard this term before also. So, APIs are nothing but a set of definitions and protocols for building and integrating application software. So, they kind of provide you with an interface for integrating the application software. Now, if you want to interact with a computer or a system to retrieve information or perform a function, an API helps you communicate what you want to communicate to that system, so that it can understand and fulfill the request. As an example, if you consider the API design or the application programming interface design for the weather forecast service, which would specify that you provide with a zip code, and then that application would provide you with a two-part answer, that is the minimum and maximum temperature. You within a weather forecast application, it asks you for the zip code to know your location. And then when you provide it with your zip code, it gives you the minimum and maximum temperature of that particular area. So, these are what APIs are doing. Another example of APIs is your online passbooks or online banking applications that you are using. So, that means they are providing you with an interface to use a particular application. Say for a banking application, the application is allowing you to access all the banking facilities. You can create an FD online, you can check your bank balance online, you can transfer money online. So, how are you doing all this? With the help of the specific banking application. And how is that application enabling you to use all these services with the help of an interface. So, for that reason they are known as the application programming interfaces, which are basically helping you to integrate the application software so that you can use the services provided by it. Now, basically the kind of APIs that we have are REST based and WebSocket based. There are two kind of application programming interfaces provided by IoT communication. One is your REST based APIs and another is your WebSocket based APIs. Let us start with the REST based communication APIs. The full form of REST is Representational State Transfer REST. So, these representational state transfer or REST APIs use a set of architectural principles that are used to design web services. So, there are certain architectural principles, and with the help of these architectural principles, web services are designed using the REST based communication APIs. These APIs focus on the system's resources, that how resource states are transferred using the request response communication model. So, basically the communication model that is used in the REST based communication APIs is the request response communication model, which is basically based on the client server architecture. This API uses some architectural constraints. So, as I said that the REST based communication API uses request response communication model, that means it is based on the client server architecture. So, what is client server we have already studied, but let us just have a quick look again. In the client server architecture, client is not aware of the storage of data. The client's only task is to request for data. Now, where that data is stored or how that data is stored, that is not the concern of the client. It is not concerned about the server. Now, where that data is stored is basically in the server. It is the server that stores the data, and then when the client is requesting for a particular data, it is basically to the server. This request is sent to the server. So, client's job is not to be concerned about how or when what data is stored. Its only job is to request for the data. because this data is stored in the server. And similarly, server is not concerned about the user interface, because user interface is the responsibility of the client. Like when I gave you the example of user interface or client in my previous video, I told you web browser is the client application. So when you are sitting on a particular web browser, that means you are sitting on the client side, and that particular client or web browser is providing you with the user interface. That is why you are able to use a particular application on the computer, or that is why you are able to use a particular or open a particular website on the internet, because the client or the web browser is providing you with that interface. So the concern of the server is not the user interface, it is the client's concern, and this separation is needed for independent development and updating of server and client. So basically this separation is provided wherein client is just concerned about the user interface and not the storage of data, and the server is just concerned about the storage of data and not the user interface. This is important for independent development and updating of server and client. Whenever there needs to be some updation in the server and client, that can be done independently because of this separation, no matter how the client is using the response of the server and no matter how the server is using this request of the client. So both are independent of each other. Now next thing is this first constraint, as I said, is the architectural constraint, is the client server model which is used here. Client is not concerned about the storage, and the server is not concerned about the user interface. Next constraint is your stateless. So when I say stateless, it means that each request from the client to the server must contain all necessary information to be understand by the server. Now client is sending a request to the server. It must be in a format, or it must be in a manner so that it is clear, unambiguous, server can easily understand it. Say for example, if you want to type the URL of a website called Facebook. Now if you type www.facebook.com, the server will come up with the response and display the Facebook page on your client side or on your web browser. But if you do not send the request properly, that means you simply write www.facebook, or you do misspell Facebook, you do not write the spelling of Facebook correctly, so obviously the server is not going to respond you because it would not understand your request. So whatever request the client is sending to the server must contain all the necessary information that could be understood by the server, because if the server can't understand the request of the client, then it can't fetch the request data in a proper manner. That's quite obvious. If it doesn't understand the request, it won't be able to fetch it from there. Next constraint is cacheable. When I say cacheable, that means in response, if the cache constraints are given, then a client can reuse that response in a later request. So this means that when in response to a client's request, a server gives cache constraints, then the client can reuse those responses for later requests also. Now what is cache constraints? To understand this statement, you must understand what cache constraints are. Basically, cache constraints require that the data within a response to a request, the data which is sent as a response to a request, can be implicitly or explicitly labeled as cacheable. Now if this data which is sent by the server as a response to the request of the client, if it is labeled as cacheable, then the the cache which is on the client side is given the right to reuse that response data. That means next time if the same data is required by the client, it will not have to send a request again to the server, it can reuse that data from its cache. But if the server's response to a client's request, the data is not labeled as cacheable and it is labeled as non-cacheable, then the client cannot store that data in its cache, and in that case it cannot reuse that data. So even if the second time it wants the same data, it will have to send the request again to the server for that data. So this is the difference between cacheable and non-cacheable. So if a response by the server is labeled as cacheable, that particular data can be stored in the client's cache memory and can be reused later. But if the response by the server is labeled as non-cacheable, then that data cannot be stored in the cache memory of the client, and when that data is again required by the client in future, it has to request again to the server for the same data. So, this is what I mean by the cache constraints. So, basically it improves the efficiency and scalability of the system without loading the extra data. A RESTful web API is implemented using two protocols. One is your HTTP protocol and other are some of the REST principles. The next type of protocol that is used for the communication APIs in IoT is the WebSocket. As I told you that these APIs use REST and WebSocket to communicate between server and system. So, REST we have discussed, now we are going to discuss the WebSocket. So, WebSocket based communication APIs, in this kind of APIs basically it allows bidirectional full duplex communication. Bidirectional means the data can travel at the same time in both directions. One party can both send and receive data at the same time. So, it does not have to wait to send its data while it is receiving, or it does not have to wait to receive its data while it is sending. It can both send and receive at the same time, and it is full duplex communication wherein both the parties can both send and receive data between server and client using exclusive pair communication. Now, in the WebSocket based communication API, the architecture that is used is the exclusive pair communication model. Now, in our previous video also we have studied exclusive pair communication model. This basically means that the connection between the client and the server is a dedicated connection and it cannot be used by all. It is exclusively used by a particular pair of client and server. So, this API uses full duplex communication so that it does not require a new connection setup every time when it requests new data. Otherwise, what happens is that every time you require new data, you have to set up a connection. But if it is a dedicated connection, so until and unless you release the connection, every time you request a new data, you do not have to set up a new connection. Using the same connection, you can request data multiple times. By you, I mean the client. The WebSocket API begins with the connection setup. Obviously, if it is using an exclusive pair communication model or a dedicated connection, obviously in that case it has to begin with the connection setup, wherein the client sends a request to the server for connection setup, then the server responds with the request, then the client starts sending the request. When the client is done, then it sends a request for connection release. When the server approves, then the connection is released. So, this is all the phases of connection establishment and connection termination in an exclusive pair communication model. So, this is what is being done in a WebSocket based communication API, since it is following the exclusive pair communication model. So, what happens here is that the WebSocket API begins with the connection setup between obviously the server and the client, and if the WebSocket is supported by the server, that means the server gives a positive response, then it responds back to the client with this successful response after the setup of the connections server, and the client can send data to the server, and server can send and the client can send request to the data, and the server can send the response back to the client. That means client and server can send data to each other in full duplex mode once the connection has been successfully established between the client and the server. Now, this type of API reduces traffic and latency of data and makes sure that each time when we request new data, it cannot terminate the request. So, basically traffic is reduced here obviously for the obvious reason that there is only one pair of client and server. So, the traffic would only be from the client side, one client side, and not multiple clients. So, that definitely traffic is reduced. Also, then the latency automatically reduces, because when there is less traffic, the data the client would get a faster or a quick response. So, obviously the latency is also reduced, and this makes sure that each time a client requests a new data, it cannot terminate the request, because the request is terminated only when there is huge traffic and server is not able to respond to all of them. But here the server is exclusively for that particular client, so obviously it cannot terminate the request by the client. So, this is your IoT communication based API. So, now we have completed the logical design of the Internet of Things, and we have covered all three elements, that is the IoT functional blocks, IoT communication models and IoT communication APIs within the logical design of Internet of Things.